Hi guys, welcome to Code Bashers. So guys, I know many of you must be from 2025 batch. Okay, so this is the starting of your placement season, and we at Code Bashers are also starting the placement season of 2025 batch by making videos regarding Accenture. I know many of you were on the Telegram and saying, sir, that from next month onwards, Accenture will be coming to our colleges and the assessment will be starting. So please make some series regarding Accenture. So guys, here I am that I am starting the coding series for Accenture previous year coding questions. Okay, so this is question 1. Guys, I promise you that every day I will try to put in more and more information about Accenture, because see, this is the first time for 2025 batch. I am also very excited and I know you are also very much motivated for learning these things. Okay, just make sure that you are hitting that subscribe button and like button for this video. And guys, one more thing I want to highlight, that what I have done, I have made a dedicated Telegram group for Accenture exam on campus discussion for 2025 batch. What will happen here, once you join, so there will be a lot of discussion regarding Accenture exam. I know you will be having many confusions regarding what is the process, how everything will happen. Believe me, from 2021 2022 I am making videos regarding different companies, and Accenture is one of them. So I can help you in resolving your queries. So do join this group, it will be very much beneficial for you. Okay, the link of this group I will give in the I button or in the description box. And one more thing, or if you will search on my channel Code Bashers, you will see that I have a dedicated playlist for Accenture coding question, wherein actual coding questions which were asked previously were discussed. Okay, so some of them were missed, so I am starting this series of previous year coding questions. So I will be helping you here and will be posting more and more coding questions here. Okay, and going forward I will try to post daily about some previous year things for Accenture and some experiences. So make sure that you are hitting the like button and subscribe button also for this channel, and you are present on this channel. So guys, now let's start this video, and once again welcome to Code Bashers. Okay, so guys, first of all, I will be discussing the question, then I will be discussing the approach of this question, and finally the coding part I will be discussing. Okay, so make sure that you are watching this video till the end. So question here is, just a second, let me just correct this. Okay, so question here is, you are given a program to find count of magical numbers from 1 to n. Okay, a magical number is defined by the following criteria. So there are two criteria given, 1 and 2. So there will be a number n that will be given to you. So from 1 to n, you will have to find all the magical number. Now what is a magical number that is fulfilling these two criteria? Let's just read one by one. So first is replace 0 with 1 and 1 with 2 in the binary string. I know it's a bit confusing. I will try to explain you with the help of example, input and output. Don't worry. Next is calculate the sum of digits of the modified binary string. If sum is odd, it means it's a magical number. Okay, let's just see the input. So input will be n. Okay, so input is 5. So what question says that we have to find the magical number from 1 to n. N is 5. So from 1 to n, what will be the number? 1, 2, 3, 4, and 5. Okay, we will do one by one. First step. Okay, first let's consider this first number. First let's consider this one. Replace 0 with 1 and 1 with 2 in the binary string. So what is a binary of 1? What is a binary of 1? So binary of 1 is 1 only. Okay, binary of 1 is 1 only. Now we have converted into this binary form. Now what it says, replace 0 with 1 and 1 with 2. So first we have to convert into binary form, then we have to replace 1 with 2. So this 1 will be replaced with 2. Okay, then this first step is done. Next is calculate the sum of the digits of modified binary string. If sum is odd, it means it's a magical number. So calculate the sum of digits of the modified binary string. So what is a modified binary string? So this is this modified binary string. So what will be the sum of modified binary string? It will be 2. It will be 2 only. So it is even. So this 2 is even. Okay, so once you have calculated the sum, if the sum is odd, it means it's magical number. So the sum is even here, so it is not a magical number. Okay, so I know again the things might not have been clear to you. Let's just move towards the next number. First step, what was it? First step was to convert it into the binary form. What is the binary form of 2? It is 1 0. Next step is what? Replace 0 with 1, 1 with 2. So replace 1 with 2 and 0 with 1. So 2 1 will become binary string. Next is what? Calculate the sum of these digits of the modified binary string. So calculate the sum of these digits. So 2 plus 1, it becomes 3. So 3 is odd. So it's a, yes, it is a magical string. Next example, let's move towards the next example. Let me just bifurcate it. Okay. Next example is 3. Okay, first let's just convert it into the binary form. So it will be 1 and 1. This is the binary form of 3, normal binary form. Then we will apply the logic of magical number. Replace 0 with 1, 1 with 2. So 1 is replaced with 2. Again 1 is replaced with 2. This is the modified binary string 2 2. Again the second step, calculate the sum of the digits of the modified binary string. So sum of the digits is 4. Sum of the digits is 4. Okay, what is it? It is an even number. So we know that if the sum is odd, then only it's a magical number. So till now only this second 2 was the magical number. 4 is also not a magical number. Moving ahead, what is 4? So again, let's convert it to the 4. What is the binary number? 100. This is the binary form of 4. So again, let's convert 100 to the required one. So 1 is replaced with 2, 0 with 1, again 1. Next, calculate the sum of the modified string. So the sum is 4. So it's an even. So it is not a binary number. It is not a binary number. Next is 5. Sorry, not a magical number. Next is 5. 101 is the binary form of 5. Again converting the modified one. So 1 is replaced with 2, 0 with 1, 1 with 2. Again we will add these all number. 2 plus 1 plus 2, it becomes 5. So 5 is odd. So yes, it is a magical number. So from 1 to 5, 1 to n, how many magical numbers are there? So total 2 magical numbers are there, 2 and 5. So what we have to return? We have to output the number of magical numbers. Okay. Just 1 second. You are given a program, find the count of magical numbers from 1 to n. So how from 1 to n, how many magical numbers were there? Total 2. What were they? 2 and 5. So what should be the output? Output should be 2 only. So output is 2. That is there total 2 magical numbers from 1 to 5. I hope the question is clear to you. Now let's just quickly move towards the approach. The things will become more clear in the approach, and then we'll move towards the coding section. Okay. And again, before moving ahead, first thing I want you guys is to hit that like button. And second thing is that write in the comment section that what is your batch, what is the expected date for Accenture interview, what is your college. These three things you should mention. Again, I'm telling you, write your batch, that which batch you belong to, what is the name of your college, and when Accenture is coming to your campus for hiring. Okay, what is your expected date, and is it an on campus or an off campus hiring? Write in the comment section. Okay, there will be more understanding between uh, both of us. Okay, and again, do join the Telegram group, because lot of discussions regarding Accenture on campus exam will be happening here. So do not miss anything, just be present here. Now let's just quickly move towards the approach part of this question, and then we'll move towards the coding. Okay, so guys, for solving this question, what we will be doing, we will be using a bit masking approach. Okay, so it will be like good concept for you to understand. Like two operators are very necessary for this concept. One is this AND operator, and another one is this right shift operator. Now let's just first understand the AND operator. Okay, so if we have a bit binary string as 111, and we have another string as 0001, and we do AND operation, so what will be the output? So 1 and 1, we know it is 1. 1 and 0, it is 0. 1 and 0, it is 0. 1 and 0, it is 0. So doing this binary operation, or doing this AND operation with 1 gives us 1 only. Okay. So what can we conclude from here? Okay, let's just see one more example. So 1 1 1 1 0 0 0 0. Okay. So 1 and 0 0, 1 and 0 0, 1 and 0 0. So it gives us 0 because this bit was 0. So all these things 1 and 0 becomes 0. Now if we like, if let's suppose we have a number called 15. Okay, what will be the binary form of 15? So 8 plus 4 plus 2 plus 1. This is the binary form of 15. Okay, now this is the least significant bit. Okay, this is the least significant bit. This is the least significant bit, and this is the most significant bit. Most significant bit. Okay, now if I want to, if let's suppose I have this binary number. 1, 1, 1 and 1. I want to find that whether this bit is 1 or not. See, we know that 15 binary is 111, but in code how we will find that, okay, currently which bit is there. So if I want to find this bit is 1, if I want to find that this bit is 1, what I will do, I will just do an AND operation with 1. I will do just an AND operation with 1. Okay, so this will become 001. And if this bit was 1 and I have done an AND operation with 1, the result will be 1 only. If this bit was 0 and I have done an AND operation with 1, then what will be the answer? 0, 0, 0, 0. So 0. So to find the least significant bit, to find out the least significant bit, whether it is a 0 or a 1, we do AND operation with 1. If the resultant is 0, it means that this bit was 0. If the resultant is 1, then it means that this bit is 1. Now I know that, see, you won't be understanding anything. But once I start to write the code, then many of these things will become relevant to you. Okay, we have understood the concept why we are doing AND operation. We have understood the concept of least significant bit and most significant bit. Now let's just understand the concept of right shift operator. Okay, if you are finding this information as useful, do hit the like button. And if you are finding this information as like it is of no use to you, just like dislike, you can dislike the video, but make sure that you are like seeing, if you have not understood this, you are seeing the code also, that logic that I will be writing. Okay, it is not a difficult logic to write, but it's like these things are you should understand these things. Okay, let me just remove all of this. Okay, just a second. Yeah, so now let's just understand the right shift operator. So currently the 15th binary was 111, so any binary you can take. Now if we do this binary right shift 1, if we do right shift 1, then what it will become, it will become 3 ones. So this least significant bit will be gone if we are doing right shift, because it will move towards the right, there is nothing at the right, so these 4 bits will become this. Now we have 111, and again we do right shift by 1. So what will happen? It will become 2 bits, because this least significant bit will become again of no use. Then double 1 right shift by 1, again it will become 1, and again 1 right shift by 1, it will become 0. So this is the use of right shift operator, that once we do right shift operator, this number tends to reach to 0. Okay, these numbers tends to reach to 0. Okay, again I know the things will not be much clear. Once I start to write the code, the things will become more clear. Okay, just one more example of right shift operator I want to tell you. 1011, if we'll do right shift by 1, it will become 101. Again we'll do right shift by 1, it will become 10. So again we'll do right shift by 1, it will become 1. Again we'll do right shift by 1, it will become 0. So when we do multiple right shift operators by 1, then it tends to make them to 0. Okay, now I have like and made you understand the two different concepts. One is AND operator, one is the right shift operator. Now let's just move towards the coding part, and then the things will become more clear to you. Okay, so let's start by writing the code. So first of all, we will be declaring n. See, I am writing the code in C++. You can write in Python also, Java also. Every language is suitable in Accenture. First word is n. Next is cin of n. And why? What is n? That 1 to n we have to find how many magical numbers are there. Now n. Okay, so n is, let's suppose, 5, as we have taken as example. So what we'll do, we will loop from 1 for int I equivalent to 1, I less than equivalent to n, I plus plus. Okay, and for every number we will try to find that whether the current number is from 1 to n, whether the current number is a magical number or not. What are the steps for magical number? Okay, what were the steps for magical numbers? It was simple. Convert to binary. Okay, next step was make 0 bit to 1, 0 to 1, make 1 to 2. Okay, make 1 to 2. Next, what was we were doing? Add digits of resultant binary string, and check whether sum is odd or even. Okay, so these were the steps that we were following. So let's just do them one by one. First, convert to binary. Now see guys, there is one process that first we convert entire one entire binary sorry first we convert entire this integer to binary, then we make 0 to 1, then we make 1 to 2, then again with that we convert to resultant binary string, and then again we do the sum. That is a bit tedious task. What we will do, for the current number, while I is greater than 0. Okay, while I is greater than 0, I is the current number, it can be any number from 1 to n. What we will do, see here, at every position we have to find, let's suppose we have 5 only, okay, 5, and we are, this is the binary form. At every position for every number we have to find that what is this bit. What we'll do, we will try to find that what is the least significant bit. If it is 1, we will convert it to 2. If it is 0, we will convert it to 1, and we'll simply add it in a sum variable. Okay, sum variable. So for every number outside the while loop, what I am doing, I am taking a variable as sum, initializing it with 0. While I is greater than 0, we will try to find that what is our least significant bit. Okay, this is our task. We have to find that for this number, what is for this I, what is our least significant bit? Is it 1 or is it 0? So what we'll do, we will do AND operation of that I and 1. We will do AND operation like this. Okay, so if it was 1, then is this condition was successful. If it was 0, then we will move towards the else condition. If it was 1, what we need to do, that convert that 1 to 2 and then add it into the sum. So what we'll do, sum plus equivalent to 2. I hope this step is clear to you. First, we have checked whether the least significant bit is 1 or 0. If it is 1, we needed to convert that 1 to 2, and we have to, next step was to calculate the sum, check whether the sum is odd or even. Okay, so that we are simply straight away added that 2 to our sum. Else, was if our least significant bit is 0. In that case, we have to add 1. Let's digest this step only, that we have I. Let's suppose our current I was 4. Let's suppose our current I was 4. The binary equivalent of 4 is 1 0. Okay, then what we are doing, we are finding the least significant bit. We are doing step by step. We are finding the least significant bit. If it is 0, we are adding 1. If it is 1, we are adding 2. Next thing, see, now the role of this least significant bit is done. Now what we have to do, we have to go towards the next bit. For the next bit, we have to again find whether it is 0 or 1. So for that, what we do, least significant bit is done. We have to remove this least significant bit, and for removing this least significant bit, what we needed to do, the right shift operation. So I is equal to I right shift by 1. So by this operation, this bit is removed now. Least significant bit is removed now. So this we have done right shift by 1. So this has now become 1. So this is not one integer, but this is 1 as a binary. So again this loop will run. So while I is greater than 0, so yes, I is greater than 0, it is 1. Again we'll check if this binary and 1, is 1 or 0. So if it is 1, we are adding this sum plus equivalent to 2. Otherwise we are adding sum plus equivalent to 1. And again we are doing right shift by 1. So if this is, again we are doing right shift by 1, then it will become 0. So once this will become 0, so the while loop for this particular I will tend to 0. And now we have our sum into this sum variable, and now we can check that if our sum is odd or even. So sum mod 2 double equivalent to 0, sorry, not equivalent to 0, then we are doing count plus plus. So magic numbers, count plus plus. So let's just initialize this outside the main for loop. Int count equivalent to 0. I hope this entire logic is clear to you. If you still have doubt, just repeat it from the starting perspective, in which I have explained the approach and code. The things will become very clear. It will be very simple. This while loop will be repeated for every number from 1 to n, and in the end we will check whether that sum is a negative or odd or even. If it is odd, then we are doing count plus plus, and in the end we are simply printing C out count. Okay, so if I give the input as 5, our resultant should be 2. Okay, our resultant should be 2. So let's just see here. Okay, So sample input is 5 and our output is not coming. Okay, okay, just a second, one mistake I think I have made. What is that? See, I am using this I variable in the loop also, and I am tending it this I into 0 also. So what we can do is int x is equivalent to I, and now I tend this, all the operations are done on x instead of I. So this is the, I think, the main problem that is happening. Let's just see if there is any other scope also. Let's just run it. See in, and we have done for int I plus plus. Okay, see, now the output is correct. So this was the minor mistake that you have to see, and this is the output that it is giving. So it is giving, it will give the correct output for all the cases that will be given to you in the exam. So I hope this entire question is clear to you, the approach is clear to you, the code part is clear to you. Okay, so even if you have any doubts, you can write in the comment section. Do join the do make sure that you're present on this channel, because more such videos I will be posting in this channel, and every day you will be learning a new concept. Okay, it will be very much beneficial for you for the Accenture exam. So make sure to join this Telegram group, make sure to subscribe this channel, make sure to hit that like button, because it will motivate us to make more such videos. This was it for this video. Thank you for watching this video.